So a mineral is a naturally occurring substance with a unique crystalline structure and composition. And they're located on page 16 of your reference tables. The last page of your reference tables gives you a list of the different minerals and also gives you some characteristics about each. And we're going to talk about how to identify minerals over the next few minutes. So the first thing in identifying minerals is we look at the luster. And generally, they're characterized as either having a metallic luster or a non-metallic luster. So a couple of examples of a mineral with metallic luster is galena and also pyrite. And if you look closely at these, you can actually see the metallic nature. They glint like metal, the way they reflect the light. A couple of minerals with a non-metallic luster is olivine and calcite. And these two minerals don't reflect light like metal. So a metallic mineral, a metallic luster is going to look like metal. Non-metallic, it does not look like metal. Another way to characterize a mineral is based on the hardness. So it's the mineral's resistance to being scratched, and it's measured on the Mohs scale of hardness. So if you look at the Mohs scale, they often reference being able to be scratched with a fingernail or a penny or a nail, and also related to a piece of glass. Okay, so let's calculate some hardness. We're gonna scratch some glass here. All right, so here is our glass plate. And if we wanted to figure out if a mineral is harder or softer than glass, then we're gonna just rub a mineral on that. So let's try this with our mineral galena. Okay, so if I rub it on the glass, it doesn't leave a mark. Okay, it doesn't leave a scratch. So that's telling us that the galena is actually softer than the glass plate. And if we look at our reference tables, we find that galena has a hardness of about 2.5. Okay, the hardness of plate is about 5 to 6. Let's try the mineral olivine. If I scratch this on the plate, it does leave a scratch behind, which indicates that olivine is actually harder than the glass surface. And on our reference tables, we can find that olivine has a hardness of 6.5. All right, another way that we can identify a mineral is based on its breakage pattern. And we can talk about cleavage and fracture. Cleavage just means that it breaks in a nice organized pattern. So if we look at this sample of calcite here, we can see its breakage lines are along planes. It's nice flat surfaces where it's been broken. Okay, so this is a good example of cleavage. Another good example of cleavage is this mica. And we could actually break this into sheets. Okay, so the breakage pattern here has specific planes. Okay, so we have cleavage here. A couple minerals with fracture is this quartz sample. And if we look at this quartz, how it's been broken, is there's no pattern to the breakage. It's very uneven and irregular. So quartz has fracture, and so does olivine. How this has been broken, there's no pattern. It's just a very uneven surface. Okay, so we have cleavage and fracture. A fourth way that we can identify or characterize minerals is based on streak. And basically, streak is a powder left behind after that mineral is rubbed on a porcelain plate. So here I have my porcelain plate, and we're going to try olivine. We're just going to rub it against the porcelain and see if there's any powder left behind, if any. Okay. So there's no powder left behind here. Now if we try a mineral like galena, we rub it along the porcelain plate, we're going to see a streak. The powder is a dark color. Okay, so this mineral exhibits a streak. And the last, and the final identification that we're going to be practicing today is the acid test. And certain minerals, if they contain calcium carbonate, they're going to react with acid, and they're going to react with bubbles. Okay, so I'm going to take this acid, and I'm just going to put some on this mineral, and we're going to see some bubbling. Okay, and what that bubbling tells us is that calcite actually has calcium carbonate in here, in that mineral. So that concludes our review of minerals, and we're going to move on to the rocks now. And the first rock that we're going to talk about are igneous rocks. And igneous rocks you can find on page 6 of your reference tables. There's a whole identification chart on page 6 of your reference tables. And just as a reminder, igneous rocks form from cooled and hardened magma or lava. And if they were formed from cooled magma, which is located on the inside of the earth, they're considered intrusive. And one of the key identifiers of an intrusive igneous rock is their coarse texture. And this is a sample of granite, and if you look at the granite, you can actually see individual crystals. Okay, so this is coarse-grained and large crystals. The large crystals form from the very slow cooling of that magma material. Igneous rocks can also be classified as extrusive, which represents rocks formed on the outside of the earth. And these are generally fine-grained. And there's also two other key characteristics of these types of rocks. One is it may have a glassy appearance, as in the case of this obsidian, which is indicative of super fast cooling. And the other characteristic is, as in this sample of scoria, gas pockets. And we call this vesicular. It exhibits gas pockets. Okay? So whereas igneous rocks are formed from cooled and hardened magma or lava, sedimentary rocks generally form from compaction and cementation of smaller sediments and or rocks. So one of the key characteristics of sedimentary rocks is that they have visible sediments in them. So if you look at this piece of conglomerate, you can actually see smaller pieces of rocks glued together to form a bigger rock. And this is a sample of conglomerate. You can see the pieces of sand and the pebbles. Okay, another key characteristic of sedimentary rocks is the evidence of fossils. And if you see here, there's actually some fossils of shells. And those are two key ways to know a rock is sedimentary. And the third type of rock are metamorphic. These are formed when existing rocks undergo intense heat and pressure. And when they undergo that intense heat and pressure, they actually form different rocks. And the most common way to determine a rock is metamorphic is it has both foliation and banding. Foliation is layering of the minerals, and banding is a type of foliation where the minerals are separated into thicker bands. And if you look at these rocks, you can actually see a zebra-like pattern of these bands. And both sedimentary and metamorphic rocks are both characterized in more detail on page 7 of your reference tables.